Hi, welcome to another installment of Car Supply's online virtual training series. Today we're going to discuss the blower motors used in the post-FER furnaces. All right, the name of this module is actually called Motor City. My name is Adam Tornator. I am a technical service advisor and instructor for Car Supply. So let's get right to it. The three motors we're going to discuss today are going to be a fixed constant torque motor, otherwise known throughout the industry as the X13. The next will be the variable constant torque motor, and the final and third will be the variable constant airflow. These three different types of motors are now used through the entire furnace lineup of ICP's offering. All right, so let's get to the nitty-gritty and talk about the features of each motor. All right, first things first, we'll talk about the variable constant airflow. Brushless DC motor. It is a true variable speed motor, which we'll talk about more here in a few minutes. Has a speed range of 200 to 1300 RPMs. It is a constant airflow motor. 80% peak efficiency, has an average power rating in the cooling mode of 413 watts, average power in the constant fan mode of 83 watts. It can be troubleshot with TechMate Pro motor tester and is actually a two-piece motor. So the motor and module are actually separate. On the variable constant torque motor, it as well is a brushless DC motor. Has a variable torque command, so the signal going to the motor is a variable torque signal. Has a speed range of 600 to 1100 RPM. It's controlled by torque bands. Peak efficiency is 80%, just like the variable constant airflow. Has the same power ratings, average power consumption and cooling, which is typically your highest speed at 413 watts. 83 watts in the constant fan mode. Can be troubleshot with a multimeter and is a one-piece assembly. And the fixed constant torque, which is often referred to as a multi-tap ECM, standard ECM, or an X13 motor. It as well as a brushless DC motor, has a tap select speed tap selection, has a speed range of 600 to 1100 RPM. It is a constant torque motor and 80% peak efficiency, just like the other two. And the average power consumption in the cooling is 413 watts, which is the same across the board. However, on the constant fan, you are limited to speed, so it does have a little bit higher rating on the constant fan speed at 200 watts. This also can be troubleshot with a multimeter and is a one-piece motor as well. All right, the variable speed constant airflow motor. All right, this is what we consider in the industry as a true variable speed motor. Okay, this is a fully communicating motor, which means it communicates directly with the board to and from. It receives signals from the board. The motor also sends signals back to the board. Okay, so on this motor, you're typically going to see an extra wire in the control side. Okay, that extra wire is the feedback that is returning to the board. Okay, and what this allows it to do is it allows the motor to communicate the RPM back to the control board and allow the control board to make adjustments against the RPM speed. So as it receives the feedback of the RPM, it can make its adjustments to overcome additional static pressure to a certain extent. All right, you're also going to get the best humidity control with this type of blower, or with a communicating type blower. And as you use it with our communicating control, like the Ion or the Observer, it will give you the best control for the best comfort in the home. All right, now these motors were also used in two models in the pre-existing furnace lineup prior to the FER rule that went into play in July of 2019. So prior to that, you would have seen these in the G9 or F9 MAC, as well as the G9 or F9 MAE. And now let's talk about the variable constant torque motor. All right, this is a motor that receives a pulse width modulation signal. And for those of you that don't know what pulse width modulation is, pulse width modulation is a voltage pulse. Okay, this pulse typically happens so quickly that a multimeter is not capable of picking it up. Therefore, the meter typically averages the voltage out. Okay, so this motor is typically, your airflow is set up via dip switches on a control board. Okay, and then the control board will output the signal to the motor based on the mode that it's calling for and the stage that it's calling for. All right, so all of the control board, all of the programming for the speeds is in the control board based on the dip switch settings. All right, this is one-way communication, which means the control board sends the signal to the motor, and that's it. Okay, so it's just a dedicated command to the motor. All right, and you would have seen these in the pre-FER furnaces in the G9 F9 MVT model and the G9 F9 MVE model. And last but not least, we have our fixed speed constant torque motor, or X13 if you will. Okay, this is the only motor now that currently actually has the speeds programmed into the motor module. All right, so you'll typically have 5 speed selections. However, be cautious because some manufacturers do not program all 5 speeds in the motor. All right, it's typically set up by an installer when they do a startup on a new furnace. There is no communication whatsoever between the control board and the blower motor. Again, all the programming and algorithms are programmed into the motor module, so the control board simply sends a 24-volt command to a speed tap on that motor. And in the pre-FER furnaces, you would have seen this in the G9 or F9 MXE, as well as the G9 or F9 MXT. On the variable constant airflow motor, you're going to see these used in the G9 or F97 CMN or G96 or F96 CTN. The CMN is a fully modulating furnace, and the CTN is a communicating 2-stage furnace. With the new FER changes in the furnaces have also had some control board upgrades. On these furnaces with control boards and with the variable speed motors, they now have a self-check diagnostics feature. So to enter this self-check diagnostic mode, you must remove power from the furnace, disconnect R to the thermostat on the control board, or if you're using a communicating unit or a communicating thermostat, you must disconnect the 4-pin green connector in the upper left corner of the control board from the thermostat. Once you've done that, you can turn on the set switch, switch bank 1, switch 6 to the on position, and then proceed to power the unit up to enter the test mode. Once you enter the test mode, the process will proceed as follows. Your inducer is going to energize at medium speed, and it will stay energized through almost the entire process. Then your hot surface igniter is going to energize for 15 seconds, followed by your blower motor being energized 15 seconds after that. Okay, and your blower and inducer are going to de-energize at the same time at the end of the cycle. Once the cycle's complete, a heartbeat on the LEDs is going to indicate that the inducer, the gas valve, and the blower motor have all checked out okay. However, the hot surface igniter must be checked by a visual inspection by the technician. If there was an issue at the end of the self-check cycle, you will get a fault code as follows. A 2+5 will indicate some sort of setup error, which typically means there is some sort of dip switch or something like that that is set improperly on the control board. A 3+5 is going to give you a gas valve fault, which could be a faulty gas valve or some sort of faulty wiring or connection between the control board and the gas valve. 4+1 is going to be a blower motor fault. Again, could be an issue with the blower motor itself or just a connection, as there are Molex plug connections between the control board and the blower motor. And a 4+2 is going to be an inducer motor fault. Again, could be directly related to the inducer motor or a connection between the control board and the inducer motor. We also have a motor simulator tool accessory that is available for technicians. All right, this tool assists in checking the motor circuits through the control board. All right, it sends a signal back to the control board as if you had a good motor. All right, it also includes a 16 to 4-pin conversion harness if you're going from the 16-pin connector to a 4-pin connector on the motor. And the process to use this tool is very simple. You're just going to connect the motor harness to the simulator via the adapter that comes with it, verify that line voltage is present to the motor, perform your component self-test, and then read the status codes at the end of that self-test. This motor simulator also works on the inducer as well. All right, you can connect it to the inducer harness, perform the component self-test, read the status codes, and the simulator's 120 volt LED indicator box above the Molex plug. So at the end of your self-test, you want to record the fault. And I will forewarn you, those LEDs and fault codes, the control board runs through them very quickly, so you have to pay close attention. All right, record your fault, remove the power, and then reset the dip switch back to the off position, reconnect your stat, grab your tools, engage your brain, and power the unit back up. We say engage your brain because you may have to think outside the box when it comes to blower motor issues. And now we get to the motor troubleshooting. All right, if you received the 4+1 fault in the self-diagnostic check, that's going to indicate a motor issue. Like I said before, it could be a connection issue between the control board and the motor, but if there is no connection issue, you can separate the module from the motor and do a couple of quick tests to tell which is faulty. Okay, you've got a 5-pin high line voltage or high voltage connector from the indoor fan control, and then you've also got a 4-pin communication or control voltage connector from the control board to the motor as well. Another quick issue that I'd like to point out, ECM motors, as we talked about before, they can overcome certain scenarios to an extent. All right, they are a little more sensitive to high static pressure, but then when you're testing them, they also have to have a load on them. Okay, if you disconnect the motor and you run the motor without a blower wheel attached to it, you're going to end up burning it up. Okay, so be cautious. Make sure you keep it attached to the blower wheel, to the blower housing. Otherwise, you could see erratic motor behavior. All right, you want to keep it connected to a load. Okay, so verifying high voltage to the motor, on your 5-pin high voltage connector, you're going to have a black wire going into your L1, a white wire going into your L2 or neutral, a green wire going into the ground, and then a yellow jumper harness. Okay, the jumper in the harness indicates that it's a 120 volt motor. Most people don't realize this, but ECM motors are typically dual voltage motors. And if the jumper's installed, it's 120 volts. If the jumper's removed, it's a 240 volt motor. So checking for your high voltage, simply check between the black wire and the white wire. Okay, if for some reason you don't have voltage there, check between line 1 and ground and make sure that you do not have a broken neutral. And of course, on a 240 volt motor, you're going to check between line 1 and neutral, and you should have 240 volts or maybe even 208 volts if you're in a commercial application. All right, but another thing to point out is that we have no yellow jumper between the 4th and 5th pin on this harness. All right, next on the list, you want to verify the control signal. There are 3 different ways to verify the control signal on a variable speed motor. Those 3 options you see on the screen here. The TechMate Pro, I personally have used this tool in the past as a very great tool, but it is a simply go or no-go tool. We'll walk through that a little more here in just a few minutes. You can use a multimeter, and then there's also an LED light can be used with a 1,000 ohm resistor for diagnostic purposes in your harnesses, and we'll walk through all of those as well. So first we'll start with the TechMate Pro. All right, TechMate Pro, like I said, it is simply a go or no-go tester. It is basically going to bypass the control board and send a signal to the motor to bring the motor on or turn the motor off. All right, and to do so, just power off the unit. You're going to connect the blue and black clips to 24 volts, which would be RNC. Remove the 4-pin harness from the motor. Connect the 4-pin connector from the TechMate Pro. Power the unit up until the green light on the TechMate illuminates, and then switch the switch to the on position when ready. All right, if the blower runs, then the motor and module are okay. You know it's a signal issue coming from the control board. If the blower does not run, then we know we have an issue in the motor or module. Now, troubleshooting with a multimeter. This can get tricky at times because Molex plugs have gotten smaller and smaller over the years. So you may need some long skinny probes. I personally have a set that I love that Fieldpiece makes. They're very skinny and they fit into all the small Molex plugs. So if you don't have any of those skinny probes, maybe a good idea to go out and get some. However, if you don't feel like making that purchase, you also have the option of using a small paper clip, open it out, and you can stick it back into the harness, or a small piece of thermostat wire. Works just as well. And then you just strip the insulation away, and then you can take your readings off of it. Okay, so troubleshooting from the board end of the blower control system. You're going to have terminal designations on the control board in plug number 3. Okay, we'll start from the bottom up. So plug 3-1 should be a red wire. Plug 3-2 should be a green wire. Plug 3-3 should be a yellow wire. Plug 3-4 should be a blue wire. So when troubleshooting from the board, you're going to want to check between the red wire and the green wire. Okay. Between the red wire and the green wire, you should read 12 volts DC. If that voltage is present, then check plug 13 on the motor. Now, that was your 12 volt DC supply power to the motor. Now, if you're wanting to check the what we call the serial input signal or the speed control signal, you're going to check that between 3-2 and 3-3, which is the yellow wire and the green wire. The green wire is essentially the common back to the transformer or ground, and your yellow wire should be a 0 to 5 volt DC signal, which is your speed signal to the motor. Okay, so you should be reading 5 volts DC across plug 3-3 and plug 3-2, which is your yellow and green wire. The signal will fluctuate up to 1 volt. And you can also check at the other end on the control board to verify that the signal is coming from the control board. And on the blower motor output signal, so this would be what we referenced before as the blower motor feedback or RPM feedback from the motor. You can check between the green wire and the blue wire. Okay, your blue wire is your RPM feedback from the motor to the control board. All right, so between those two, you should see between 0 and 1 volt DC, and it will fluctuate somewhere near 0. On the motor, your control connections are going to be listed as C for common, RX, which is used to designate a receive command or receive signal, T, which is designating transmit signal, and then you have a voltage. Okay, that's going to be your 12 volt supply voltage to the motor. Okay, And you could check for all of those at the motor as well as the control board. And again, here's a look at what your readings should be between all of the wires. Between the red wire and green wire, you should have 12 volts DC. Yellow wire and green wire, you should see 5 volts DC. Blue wire and green wire, 0 to 1. Again, it's probably going to be hovering just over 0. But what if you don't have the TechMate Pro? What if your meter isn't showing the fluctuation? Have no fear. You can use an LED light as well. Again, you must use a 1000 ohm resistor, but it will work as well. All right, it's going to blink at the presence of a signal. It's going to actually work similar to the TechMate Pro, where it's either either works or it doesn't. All right, so you're basically going to see the light flickering, means the signal's present. If there is no light, it means there's no signal there. It can't read it. So using the LED in the Molex plug, all right, going between your yellow and green wire, you are going to see the LED illuminate solid with voltage present. Okay, checking the serial input signal or blower speed signal, if you will. All right, this will be between the green wire and the yellow wire. The LED is going to be a little bit dimmer because you're checking a lower voltage. All right, but you should see a slight flashing in the LED. Okay, and checking the blower motor serial output signal or the feedback signal from the motor. All right, checking between the green wire and the blue wire in the harness. It's going to be dim, but it should blink. All right, just like checking the input signal to the control board. All right, it's a similar signal, but much lower voltage again, but you should still be able to see that thing blink. That will indicate that the signal is there. And just like using it on the Molex plug on the board, it can also be used in the Molex plug in the motor to check the same signals, as well as check the 12 volt DC power supply. Okay, so what do you do if you have your high voltage to the motor and you have your control voltage to the motor, but it still doesn't run? You can separate the module from the motor, all right, and we will forewarn you, power it down, wait 5 minutes before separating, because there are very, very high voltage capacitors in that module that could do some pretty serious damage. So when we give you this warning, it is pretty serious. All right, so variable speed or ECM motors are three-phase type windings. Okay, so you're going to ohm out each of the windings from one to another. All right, you should see less than 20 ohms. All right, anything over, if you test them to ground for a short, the ground, you should see well over 100,000 ohms. All right, if you're under that, that means the motor's grounded or shorted, if you will. Okay, you want to measure each one of those windings to ground to check to make sure each winding is not grounded. Okay, and motor test B, this is going to be the winding to winding resistance. All right, you should be typically less than 20 ohms. All right, it is a three-phase motor, so all of your windings should be pretty close to equal, plus or minus 10%, which is the typical rule of thumb in electrical. Okay, so now we're going to take a dive into the variable constant torque motor. All right, this is the motor that we said uses a pulse width modulation signal from the control board. This motor is used in the, and I apologize for the typo here, this is going to be the G or F96 VTN furnace. That is the current furnace that this motor is used in. And just like the previous blower, the variable constant airflow, the variable constant torque furnace as well has a self-diagnostics mode. It goes through the same process that you use on the variable constant airflow by shutting the power down, disconnecting the thermostat, or disconnecting the communicating connector from the communicating thermostat off the board. Setting the dip switch 1-6 to the on position and then powering the unit back up. And again, it's going to start with your inducer energizing on high speed and stay on through the process. All right, then you're going to have to visually inspect for the heat exchange, or I'm sorry, for the hot surface igniter to ignite. All right, 15 seconds and then it will go off. Okay, then the blower is going to energize mid-range, typically right around 50% for 10 seconds, then off, and then the inducer will drop down to being energized in the low speed for 10 seconds and then off. So being that this is a two-stage furnace, it's going to check both speeds on that inducer. Again, once the test is complete, if you'll get some sort of code. A heartbeat indicates everything is okay. 2 plus 5 gives you a setup error. Okay, it's not going to give you a blower motor fault even if the blower motor did not run. All right, because there is no feedback from the motor. Okay, so on the VCT motor, or the variable constant torque motor, like we said before, the airflow calculations are predetermined and programmed in the control board based on the model plug that's installed on the control board, the dip switch settings, all right, and then the motor functions to speed based on those settings and programs. Okay, this is an example of the pulse width modulation signal. As I discussed before, the pulse means that the input to the motor turns on and off. And oftentimes, this signal is happening so fast that a meter cannot pick it up, in which case the meter will average the voltage out and you will see a solid voltage reading. All right, so this is what it looks like on a meter. No, only kidding. Meters can't pick it up. Like I said, it reads it as an average, so we'll give you a solid voltage reading. All right. You can see a true PWM signal with an oscilloscope, but nobody has one of those. Or something. Okay, one quick giveaway on the variable constant torque motors. On that specific furnace, the LED light on the control board is powered from the same DC volt signal supply as the motor. All right, so if you have no light on that control board on the communication LED, chances are you do not have the DC volt power supply going to the motor as well, in which case you have a defective control board, and I would suggest you replace the control board at that point. However, if the light is present, further diagnostics is required. So, troubleshooting the variable constant torque motor, you'll have a Molex plug number 16 on the wiring diagram. Will come directly off the board and go to the motor. There will be a junction point between the motor and the control board. You should see a brown and yellow wire and even an orange wire on one side. So to further troubleshoot, you want to disconnect that harness right there at that junction. Okay, you want to disconnect that with no load, so make sure there's no call for blower operation when disconnecting that. All right, then take your meter and measure between the brown and yellow. Your DC volt reading, if your DC volt reading is steady, you have an issue with the motor. Okay, if your DC volt reading is fluctuating, that means the issue lies in the control board. And here we show a diagram of the connections at the motor. Okay, your black line is going to be your AC voltage hot, your white line is going to be AC voltage neutral, and green is going to be a ground. All right, and then you've got your yellow going to your speed tap on your motor, and your brown coming into the common. All right, and make a note that your common actually comes in on the high voltage connector on these motors. Normal operation readings on the variable constant torque motor, naturally between your black line and your white line you should see 120 volts. All right, and green being your ground. However, during normal operation, between the common and the brown, you should see up to 15 volts DC. Now you will have to take this measurement back to the common on the control board. All right, you will notice a drop in the DC voltage transitioning from high to low fire on the furnace because it will effectively change speeds. So what do you do if you have the line voltage and control voltage at the motor? Simple. Replace the motor. It's a one-piece assembly. No need to take it apart and check whether it's the motor or the module, because you're going to be replacing them both anyway. All right, but here we have a photo for all you curious Georges out there who love to see the insides of mechanical parts. All right, the motor and module actually can be taken apart in two pieces. However, we sell this motor as a single piece unit. All right, but just like the variable constant airflow motor, your motor is a three-phase motor, so your windings are going to ohm out as a three-phase, so that means they should be very close to equal, within 10% of each other, and you would ohm them out for shorts just like you do the variable constant airflow to a ground. And finally, we're going to talk about the fixed speed constant torque, or otherwise known in the industry is the X13 motor. All right, this is probably the most common motor we have out there. You're going to see these in the majority of the single stage furnaces. This, guys, is taking the place, or has taken the place, of PSC motors. So this is the new standard in high efficiency gas furnaces, as well as standard efficiency gas furnaces, ever since July of 2019. And just like the variable constant airflow and the variable constant torque motors, the fixed constant torque furnaces also have a self-check diagnostic on the control board. All right, to use this feature, remove the R connection to the thermostat, briefly jump or short between the test twin and common terminals. Now, if you short them for longer than 2 seconds, the board's going to automatically fall out into a flash code 10, and it's going to ignore the self-test. Okay, so it has to be just a short, brief period that they're shorted together to enter the self-checkout mode. And once you enter the self-checkout mode, the LED is going to flash 4 times, flash the previous status code 4 times. And then your inducer will energize and continue to run. 7 seconds after that, the hot surface igniter is going to energize for 15 seconds, so be on the lookout to make sure your igniter is lighting. Once this takes place, your blower will energize and on the continuous speed for 10 seconds. So one of the changes on the control boards is that you now have a continuous fan speed. Okay, so that's the speed that it's going to function at when it goes into the blower self-test. Okay, then following that, it will go into energize the blower heating speed for 10 seconds. And then following the heat speed 10 seconds, you're going to go into the cool speed for 10 seconds. All right, at which point your inducer will de-energize and you will complete the test. All right, and on the 2-stage models, like the single stage model, your LED is going to flash the previous status code 4 times. Then you'll get your inducer starting up, and then you'll get 7 seconds later you'll get the hot surface igniter, so be on the lookout for that igniting up and lighting up bright. That'll take place for 15 seconds. Following that, your blower will energize in the low heat speed for 10 seconds. Then blower will energize in the normal heat speed for 10 seconds, or high heat speed for 10 seconds, if you will. Then you will go to your cooling speed for 10 seconds. And then following that, the inducer will drop to low speed for 10 seconds and then de-energize. If you have no blower operation on the fixed constant torque motor, very simply check for 24 volts coming off the control board on your blower speed taps, and check your line voltage going to the motor as well. Then you're going to make the same readings at the motor itself. And remember, on this motor you're going to have 5 speed taps. Be sure to pay close attention to the wiring diagram as to check the speed taps you are testing. Again, checking the line voltage. Your white line is going to be your neutral. Your green with the yellow stripe is going to be a ground. Your black line is going to be hot, and your solid green is going to be your 24 volt AC common. Again, this motor has the 24 volt AC common coming into the line voltage connector. So what do we do if you have line voltage and control voltage at the motor? In this case, you are going to replace the entire thing. They are sold as one piece. So there's no need to take the control and module, the motor and the control apart for any further diagnostics. Although it can be done, it's sold as one piece, so it really isn't going to make a difference. And this will conclude our training for today. We hope to see you going forward on more of our online virtual training series. Thank you and have a great day.